Hello, and welcome to Advanced Physics for High School students. My name is Bryant Haynes from the Girls Preparatory School in Chattanooga, Tennessee, and I'll be your guide through this journey. This series of screencasts accompanies Dexter Bone and Mark McVictor's text, Advanced Physics for High School Students, presenting the important topics of the lessons, working example problems, and doing in a recording what some teachers do in the classroom. These screencasts give students the opportunity to conveniently carry their lessons with them, interacting with them when it's convenient, stopping where necessary, and rewinding where it's helpful. Many different topics are addressed in an interleaving manner, and this ordering of material is different than what is found in the majority of other physics curricula. So, for example, if you pick up a typical physics textbook, you'll see an ordering of toppings that begins with mechanics and proceeds through thermodynamics and then goes on to electromagnetism. At the end of such a course, you might find that you really know well how to handle the motion of charged particles in a magnetic field, a topic that you studied in April, but you don't really remember how to handle projectile motion because that's what you finished back in October. In the Advanced Physics for High School Students curriculum, we seek to address that issue by working you in physics a bit like you'd work in basketball practice. On the basketball court, you don't learn all there is to know about dribbling before you begin to learn to shoot the ball. Rather, you start with the basics in ball handling and moving up the court and shooting at the beginning of your basketball practice. And as time goes on, you grow in your abilities, adding more advanced skills as time passes. The same is true in this physics course. At the start of the year, you begin handling the elementary concepts for many different areas all at the same time. Things like linear motion in mechanics, and temperature in thermodynamics, and electric charges in electromagnetism. As the year progresses, you begin wrestling with intermediate topics such as two-dimensional motion and kinetic theory and electric fields. Finally, toward the end of the academic year, you're working with advanced topics like projectile motion and thermodynamic processes and charges moving in electromagnetic fields. So, when you complete the course, you've moved along parallel tracks in all the disciplines embraced by the course. This spiraling approach sets advanced physics for high school students apart from other introductory physics courses. Incidentally, shown on the cover of the text are the authors' families at the time of publication. Marlene Bone and Donna McVicker work at the table, and from left to right are Alexandra McVicker, Alexandria Bone, Victoria Bone, and Elizabeth McVicker. These are the authors' families. Now let's begin to get into some of the elementary principles of this subject. Physics is the science of energy and its transformations. We'll see that at the beginning, energy was defined in terms of forces and displacements, and so we'll need to learn how to handle motion and the forces that cause those changes in motion. Later on, we'll see energy expressed in other forms as well, such as thermodynamic energy, which we call heat, and electromagnetic energy, radiant energy, nuclear energy, and many other forms as well. We'll be examining the natural world, seeking to logically describe and to mathematically model and to accurately predict how nature behaves. Most of the topics will draw on your common sense ideas, mathematically shaping and applying them in meaningful and sometimes very novel ways. There will be many, many ideas to keep in mind. And one of your secret weapons to successfully navigating the course is to know the equations. You'll find that the equations are your guides for thinking about ideas, telling you how the physical quantities relate to each other. We'll draw on your everyday experiences to help convince you of the validity of the equations, and we'll push the equations to extract out of them all that they can tell us. I hope you'll try to connect each of the ideas to some actual physical experience that you've had, and to keep those experiences in mind as you approach each new topic. Ultimately, we want you to build a model in your head for how the world works. To get the most out of this series of screencasts, you should view them prior to attending the class when the lesson is discussed, jotting down your questions, working through examples with a pencil in your hand. What you get out of this course depends on the investment you make in it. I'm willing to wager that those of you making a good faith attempt to do the assignments will learn best what is presented. Understanding is the ultimate goal. And while it'd be nice to earn a good grade in the course, that shouldn't be your focus. Make your aim to understand, and I wager that good scores on tests and good grades on your report cards will follow naturally.